Hi, welcome back to Learning Kotlin Live, and this is the episode 14 of the series. We left yesterday at a partially solved problem, which nope, not this one. Where were we? Sort by height? Yes, I think so. Yeah. So it was like we would need this zigzag pick pivot index re-implemented. Let's see. So if actually okay, let's do it this way. So it's actually not and equals to begin. It's if this is how I'm going to do this. So assuming there is like this list, this is how we're going to zigzag. First of all, we pick the item in the middle, which is 0, 1, 2, 3, 4, 5, 6, 7, and 0 plus 7 divided by 2 is 3, so 0, 1, 2, 3, we're going to pick this one. Let's assume that this one is minus 1. How are we going to pick the next one? We're going to offset from 1, and which is this. We're going to start offset from 0, and then 1, then minus 1, and then 2. So, what we're going to do is to, if it is positive, if it is if it is non-negative, we minus 1, which makes offset becomes minus 1. And if it is negative, we inverse it and make it 1. And if it is non-negative, we add it, we make it again. If it is non-negative, we flip it and minus 1. Yeah, and we continue these until we hit the boundary of, let's see. So the boundary would actually always be on the right hand side, because if it's equal, it does not care. If you have odd items, it would be the item on the left hand side and right hand side would be equal, then it does not matter. But if the item count is even, we're going to start with the one on the left, the two middle items, and the smaller one of the two middle items, because we discard as we have mentioned before, for a divide operation in integer, like 5 divided by 2, the remainder is discarded, and this would be 2. So actually we're going to start with plus 1. That's the first index, first offset. So if 0, we're going to flip it into minus 0 and plus 1. And we're going to have 1, and the next one is minus 1. Simply flip it. So if it is so, and what's next? We're going to plus 1, flip it and plus 1. Then it is 1 plus 1 equals 2. So it's flip it and plus 1 if it is non-negative. So this is the next offset logic here. If offset is non-negative, if offset is non-negative, then we flip it and plus 1. Oh, actually it's if the offset is non-positive. Yeah, if it's If it's non-positive, then we flip it and +1. Else, we simply flip it. So let's take a look from 0, because 0 is not smaller than 0, so we give it -1. Okay, so maybe an equal here. Because 0 is equal to 0, so we flip it and +1, so it's 1. 0, oh, oops, sorry. Then 1. Then 1 is non-negative. 1 is not smaller than or equal to 0. So it's the else part, we simply flip it. Then, because -1 is smaller than 0, then we will flip it, which is 1, and add 1 to it, so it's 2. So this is how we zigzag. And we actually don't need these div begin and div end here. We simply use the begin and end every time we have it. And not cut end first. It's next offset. And a here. So so we need a boundary check here. If we hit the boundary, like if so pivot var maybe value equals to if pivot index is not equals to it's not going to sum -2, it's going to be sum divided by 2 plus offset if pivot index is larger than and or pivot index is smaller than begin, then we simply return one end of it, any end of it, because it means everything in between it is -1. So to make it simple, let's just return end. And I don't care about the sum here. If pivot index is not -1, we return it. Ow! What happened? Ouch! Why? I hope it's still there. Yeah, it's still there. Nice. However, if the next offset however, if it equals to 0, we need to decide the next one, so we return next offset. Yeah. So this is how we get the pivot index. And after that, we always have the pivot index. And next, we start from begin and end. And while left is smaller than right until it meet while left, oh, it's actually a left is smaller than a pivot left while is larger than a pivot right shift. Then at this moment we will have a candidate which we need a swap, so we swap it. So it's actually temp val temp equals to a left a left equals to a right, and then a right equals to temp. Okay, what's next? Oh, we need to first check if it is valid. If left is smaller than right. Oh, it's actually if left is smaller, larger than, and or if it is larger than and this means no left, or if okay, let's check three things here. This means O's partitioned if left is smaller than or larger than right. Oh, actually we need another check here. Oh, this is complicated. Or so in this case we check. Let's always make sure left is smaller than and. And if it is equals to -1 or it is smaller or than pivot already, it is not a candidate to swap. Likewise, if right is larger, as long as it is larger than begin, and as long as it is not a candidate to swap, so if left equals to and, then it means that let's see, wait a moment, so it's actually this. think so. It can be n plus 1. Then it would go into it. Then it would be problematic. So no. It is at most end or begin. If left equals to end, we are uncertain if this is let's need a swap or not. We check. So if left is smaller than end and right is larger than begin, no equals. This means we have a valid pair to swap. Then we swap it. However, if we don't have a pair to swap, which means either left equals to end or right equals to begin, then we might want to check if both of them begin and right equals to end. If both of them are kinda invalid, we'll need to check if, again, this thing here, we check if it is a valid pair. So it's actually R. If left, ow. Still swap it. If only one of them is valid, for instance, if A left is smaller than, so yeah, it's V bar. Actually, no, we can't change that pivot randomly. Or yes, actually we can. Oh, we can. A left equals smaller than. This means left is a valid item to swap, but right is not. So we swap. Oh, it's possible to write a swap, and it's actually possible, right? Yeah. So let's write this function swap. What's this extension here? Unit, I guess. Oh, it can be skipped, so yeah. And we take an I think we need this. Is there a list or extension function? Kotlin. Is there a list? Ah, that's the yeah, it's a list. That's the whole thing actually. We can just copy paste it. But let's check if I'm writing it correctly. Val 10 equals to, which is replace the A with this and this. Yeah. Yeah. Yeah, I'm writing it correctly, except it needs to be first of type integer and second of type integer. What else? Int swap. Yeah, that's all. Running it correctly. Swap a dot swap. Where should we swap? Left and right. Left and right. And then continue. Guess. If it is not, this is the very boundary, so a dot swap left and right. Its left is a valid one. Actually, we can't swap it randomly, I believe. Yeah, it's going to make it unmaintainable. So this is what I'm considering. If we have a case that, like for instance 1 3 2, and we pick 3 as the pivot, and if we have swapped 1 3, this is the case that start as 1 and end is 2. End is start as a 0, begin as 0, and end is 2. So we have chosen this as a pivot, and we have checked left is because left start from here, and because this does not need to be swapped, it comes to here, and right starts from here, and because it needs to be swapped, so it stays here. Oh, actually it's pivot. Well, left is smaller than pivot. What is that? For this case, because left equals to pivot index, then we need to swap it. So well, this might be an oversimplification, but let's have a larger one. 1 2 8 and 4 and 5. So it comes from here, and eventually it would be here. But on the other hand, it starts from here and it stops here. If we swap these two items into 1 2 5 4 8, how are we able to the new pivot is not guaranteed to be, so we will choose, we would somewhat mean, it somewhat means we need to choose 5 at a new pivot, but after we move here, I'm not sure if um how are we certain that 5, because 8 is definitely going to be larger than 5 if this happens. So if we swap it, everything on the left might actually be, okay, I know how to pick an example then here. Let's use 6. So yeah, this algorithm is not going to be it's not going to work. So if we start from here, and we have chosen 8 to be a pivot, then we start from 5. We stop at 5 here because 5 is smaller than 8, but we already have iterated to 8. And what I was thinking, my intuition says that we can simply swap the two items. This is also why I kinda said this is not going to work yesterday. I kinda said that, okay, we can just swap it and then we can continue. No, we can't continue. We need to do it all over again because this 5 and 6 here is actually not working anymore. So the whole structure is will need to be rewritten. So yeah, this is something that is not working. If we have if the item on the left and the item on the right are not partitioned equally. But let me take a look. Actually, Quicksort itself would run into this situation. So maybe I'm missing something. English, please. Loop forever. This is kind of what I'm doing. If I is larger than j, then return j and swap AI with aj. Why? Really? I is on the low left. High plus 1. Low, high. Why does it start from -1? Anyway, okay, it's going to be +1. Oh, because it's do while. Whatever. So, so yeah, it's going to be uneven. So when the two ends meet, I plus 1, j minus 1. If I is larger than j, return j. Is this else? I don't think so. I is larger than j. Two ends meet, which means there is nothing to swap. Then return j. But if there are more things to be swapped, oh, we swap it with, we still swap it? Does this even make sense? I goes this way, j goes this way. This means we're done, so we return j. which is the new pivot. Oh, okay. We actually kinda don't care about if it is smaller than. Yeah, why can we still swap if one of the item is not valid? So actually we don't stop at pivot here. We stop at what we have written earlier. It's begin. No, it's end. So for this case, we just simply swap them and we move on. We don't swap change pivot. We simply like this one is smaller than or equal. Don't care. Yeah, smaller than or larger than. So this one is not smaller than, so we're going to stop here. And this one is not larger than, we're going to stop here. So we're going to swap it anyway. And this is fixed, and this is fixed. And we're going to move on. Really? Is this even valid? And after that swap, we're going to find the next item, which is not partitioned, and that is 4. Do we ever update the pivot? No, we don't update the pivot. Then why? We're still going to consider 8 for this case. And this item is not smaller than. We return it as the pivot. But this does not make sense at all. Yeah, I don't think this makes sense. The low and high does not change. So we check if this one is smaller than pivot, larger than pivot. It is not. So we check if this one is smaller than pivot. It is. So we move on. Then we see that this one is smaller than pivot, and this one is not larger than pivot, so it stays and here. And yeah, we have it sorted. Okay. And the pivot is still this J here. I think it kind of works. Not quite. Okay, I'm really too far away from my college already. So actually we don't care as long as we partition it whenever we see a pair. So do we have that while AI I is I plus 1 and okay, so it's actually we don't check this boundary here. We don't need this. And the ending case is loop forever. Okay. While true, I'm not even sure if this is valid in Kotlin, but we can try, of course. So, if we have invalid pair to swap, return and no, not and, it's pivot, no, it's pivot, right? Oh, but pivot index is going to move, so this is actually original pivot index. And we need to, okay, this is, and val pivot value is a pivot index. Now, I think we still need to take care of the boundary, don't we? Yeah, what happens with when there is a boundary exception here? Yeah, this is pseudocode. I think this is because it is pseudocode, so it does not check for it here, but we need to check for it here. Okay, I think we will have tons of compilation errors. Tons. I can promise you. valid and index. That's a val. What? What can I be reassigned? Valid? Huh? This is weird. This is really, really weird. Okay, I'm really so unfamiliar with Kotlin. So many stupid syntax arrows. Sort by. Is this even ending? Zig Zag pick pivot. Not resolved. What have I changed it into? Zig Zag pick pivot index. Unresolved reference pivot value equals to original pivot index. Where? is that. Okay, I think we've solved 3 functions already, so we only have this function left, hopefully. I hate this space here. Conflicting declarations. 50, 11, 57. Pivot index equals to sum. And 24, 57? No. Oh, okay. Equals to begin plus end divided by 2 and plus offset. What are these two items? 57 and 62? Oh yeah. Zig Zag, pivot index. Finally! And I think we will have a runtime error instead this time. Very, very likely. Stack Overflow! I guess. Yeah, Stack Overflow. So it's not ending at all. At line 26. Partition. We're sort by height. We're doing sort by height non-stoppingly. Sort by height. I think it's the pivot we're picking. Sort by height. So many pain. We have a pivot index and this. Okay, so if pivot index is at a boundary, if it is on a boundary, and pivot index plus 1, so sort by height, we need to check if sort by height, oh no, actually if begin is larger than end or equal to, we don't need to sort it, return. Oh, it's still Stack Overflow, interesting. Valid begin index and pivot index. Pivot index plus 1 and to valid end index. Start with end. Well, this looks ugly, but I think this might be the problem that I'm facing. Still no. Really? We start with 0, a dot last index. On test 1, so it fails on even the simplest case. So let's run it mentally. start with 5. Let's copy paste it. This is the list. And then what would happen? Sort by height. We start to sort with here until here. Then begin is not smaller than, it's not larger than end. So we would do this valid and index. At the end, where's the end? That's the end. It's valid. And it is not equals to -1, so it's not going to do this. But this equals to -1, so it's going to move to here. Valid begin index plus plus. It's still valid, so no return. Then we start the partition. Valid begin index, valid end index. And that's 1 and 2, 3, 4, 5, 6, 7. 1 and 7. So original pivot is begin, and let's first take a look at what line 32 is. Interesting. That's not even possible. Oh, okay, this is why. Haha. So where's that 32? 32 was sorted by height. Valid begin index the first part of it. So should we check the boundary like 0 is, but it's always valid. If it is never valid, it would like run out of it. I don't know. What if we don't do this valid index check? We simply do it with, so enough of nonsense. Let's do it simply with begin and end. I think it's still a, actually no. Yeah, it's still infinite loop 20 and 21. I actually really want to know what we have partitioned in this place. So it's dying in the first partition. Actually no. Why do we call wait a moment. Where does this stack start from? Sort by height. Partition. It actually should start from line 20. What's line 20? Here. Partition. Yeah, it's 21 calling 22 and 26 to file Zig Zag. Where is it? 51. So it's actually kind of working, I guess. I don't know. That's actually pretty weird. Where's the beginning of this stack? It should actually start from this sort height 11. But anyway, okay. 802 through 8 dot less index a, and that is this function. If begin is larger than end, return, and we choose pick a pivot index. partition begin and A. And the original pivot index is the middle. Oh, is this? Okay, no. Zigzag pick pivot index. It's begin plus and divided by 2 plus offset, which is 0. And as long as pivot index is pivot index okay. Pivot index begin plus divided by 2 plus offset and what's next? If pivot index smaller than end or pivot index is larger than begin. This is just never possible. Oh, actually no, it's possible. Larger than end or so is it like never picking a smaller item? I don't think so. Pivot index is larger than end or pivot index is smaller than begin. It's and means there is no valid pivot index. Makes sense. Next offset. Flip it +1 or flip it. This makes sense too, so I don't think there's a problem in zigzag pick pivot index. So anyway, let's go back to this. Where were we? Zigzag pick pivot index. Zigzag pick pivot index. Left smaller than. We have the original pivot index. Pivot value is okay. That's a problem probably, but we're not changing that anyway. But this is not optimal, so let's change it. If A left is smaller than okay. I think this may be a problem. We should check -1 first. We only check it when it is not equal to -1. Yeah, these two lines are problematic. One of it. I don't know which one of it. Maybe this one? Okay, so that's still not solving the problem. We're going to left plus. I don't think we have problem in partition 2. Then this is really weird. So let's run it thoroughly. Have this and this and this. Then the original partition would be 0, 1 plus 2, 3, 4, 5, 6, 7, which is 8 divided by 2 would be 4, 0, 1, 2, 3, 4. This is the original partition, which is invalid. So that would be, we're going to flip it. If offset is smaller than 0, smaller or equal than 0, yes. So we make it minus 0 plus 1, so the next offset is 1. And we take a look at the next Zig Zag pivot index, which is 1, 0, 8, 8 or yeah, 0, 8, A and 1. And this time we get this one here. It is still invalid. So the next zigzag's offset would be minus 1. So this time we have this one. So that's the index, that's the pivot, or that's the pivot to be. So we have partition index, pivot index equals to 0, 1, 2, 3 here. So the first partition is 3, and then we swap them. While A left is smaller, equals to minus 1, or A left is smaller. It is smaller, so we move it to the next one, which is here. Then if this one is larger, and it is swapped. So okay, we just need the original here. So it is swapped. 180, 190. Then we move. This one is larger, and this one is still not smaller. So then we move to the next one. And we swap these two. 180, 160. So this one is larger or equal to. So we don't swap it. It's smaller. Oh, so maybe we shouldn't have this here. I'm not 100% sure why, if this is valid. Yeah, we shouldn't have this equal here. Yeah. Ow! This is not going to compile at all. Still invalid. So now we move forward to this one. This one is still larger. So this one, and this one, and this one. And then we have this, we meet at here. If there is an invalid one, what? Yeah. What happened if there is an invalid one? We don't just simply don't swap. But how about these items? These are not maintained yet. We're not going to care about that. Yeah, we don't check this here because it's going to be valid anyway, because we do this check here. Oh, actually no, it's not going to be valid. If this ever move to this is true, it would stop at pivot if there is a pivot. Because we don't have this equal here. Something is changing, I guess. This just makes no sense. Begin, pivot index, a, pivot index plus 1, and begin is larger than. We have a begin and end. Partition it. And then we have some pivot index here after that partition. I'm not sure if we can print anything, but let's try. Because it's stack overflowing, so I'm not sure if we can see the stack trace at all. Buffer overflow, that's interesting. Even if this partition is pivot index is so, if begin or end, if the partition it runs outside of begin and end, then left is begin, right is end, left plus right minus. It is impossible that they meet after. Left is I. Am I missing something? Why is it -1 here? Should it be smaller? I think so. larger than right, return left. Let's only run an iteration here. Then we can print it. So yeah, there is actually an index out of bound, which is pretty likely to be the root cause. Original. Pivot index is larger than and. Okay, so yeah, it is possible to overflow if we don't pick the middle here. Okay, I think I found a case which is risky, although I'm not sure if this should have fixed it. Yeah, the -1 here is making things complicated. Yeah, we're running out of time. I need to come back tomorrow, but I think I'm getting to it, I guess. I hope, at least. Yeah, but so the case that I think might raise problem is the case that when there is only -1. We're going to pick this at pivot and this at pivot, this begin and end, and this at pivot. No, we don't find any pivot, so eventually we pick this at pivot as pivot, and then we do the partition part, and because all of them equals to pivot, so it would this would go to here. Yeah, it's going to come here and everything just explode. So yeah, that's the case that things might go wild. And I actually don't know how I can fix this. So a possible way to fix it is in every partition we're trying to make the problem smaller, and so it's actually whenever we found Let's fix it with some really stupid way. Boolean val o minus 1 equals to true for item in A if A item not equals to -1, O minus 1 is false. If O minus 1, we're done. Yeah, but we're done. But where should we partition it? Return the middle. Then the size is not. It's not getting smaller. So it's actually sort by height. Do it even before partitioning it. Var. Oh, it's still an infinite loop. I don't know why. Where's that print? Here's that print. If it's O minus 1, how about if there's only one? Now -1. It's going to be the pivot, and it's still going to face that. No, it's not going to face that problem. Yeah, let's print for the first iteration. Okay, finally. So the first partition is 3. That's correct. And that the first partition is 4, 2, 9, 4, 16, 0, 1, 2, 3, 4, 5. 0 plus 5 divided by 2. It should be 2. Oh, it's pivot index, not original pivot index, so can we print long A? We can. So in the first iteration, as we have expected, some of the, because the first pivot is first pivot in it is 3. Oh, actually what I need is original partition. But I know the original anyway. It's 170. And this one is swapped with this one. It's this, and then -60, 190, And it's done because, yeah, the first pivot is here. Yeah, so the first iteration is implemented correctly. It's somewhere in between that caused the stack overflow. So let's have a counter here. Like, is there a way to have a global variable in Kotlin? For WebView? Why? Counter equals to 0. Oops. It's never going to be larger than 10. The next pivot is 1 and it starts to loop infinitely. Why? $150 and okay. Okay. That's a problem. I see. So it's because of the existence of -1, which makes the set never become smaller for some certain case, which is also very common for any test case. For many test cases, it is possible. The quicksort implementation is relying largely on, like, yeah, for this case, between 0 and 1, it's -1 and 150, and it's never sorted. So it's actually, to fix this, actually we can have a really stupid implementation that's coming out this here. And this O -1. So O -1 is, actually we need found to noun -1. So this is so stupid. Found 1. think that's it. No? No? Really? No? Why? Where are you, like, infinite looping again? This is so terrifying. This is so terrifying. Zero, one. Why? 0 and 1. There's only 1 minus 1. 2. Oh, found 1. Now minus 1. Wait. Less than. It's actually less than 1. Now minus 1. Less than 2. There is a less than 1. That is true and true. If less than 1 minus 1 less than false. Else less than 2. Now minus 1 is false. If less than 2 minus 1. Okay, I think this time it's going to work. Found 1, where is it? Okay. Less than 1 minus 1. Still not ending. 0, minus 1. Oh, it's not in A. In A dot in begin. Index and begin to end. Index. I hope this time I'm doing it correctly. I'm running out of patience. Output is empty? Really? Why? How can it be empty? We're making progress here, but I am really tired now. Why is the output empty here? That's so weird. Let's print every A here after a partition. Four, 2, 2, 9, 11, 16. Well, I think we're not ready for equal values. Less than 2, none, minus 1. Let's print this original pivot here. Okay, I'm tired already. Zero, 1, 2. It's going to be 2, 2, 4, 9, 11, 16. Not yet. It's 4, 2, 2, 9, 11, 16. Makes sense. And then next pivot is okay, so is it because this duplicate here makes quicksort not possible? I don't think so. The original pivot is 1 out of, actually I think we should print this here. Zero, 3, 0, 1, 2, 3, 4, 2, 2, 9, and we have 1 as a partition. Then what happened? Zero, 1, 2, 3, 0. We have this here. Pivot value is 2. Left equals to begin, right equals to end. Four, 2, 9, 11. No, 4, 2, 2, 9. A left equals to, and the pivot value is 1, which is 2. Pivot value is 2. I mean index is 2. Index is 1 and value is 2. And 4 is not, it's pointing to this 4 and this 2. So it's going to be swapped. 2, 2, 4, 9. It should be swapped at least. 2, 2, 4, 9, and it's still pointing to here, and because this one is still smaller, this one is larger, then it's going to be swapped and swap and swap again and again and again and again, I guess. So is it like infinite here? Then it should be reporting that then. It's not reporting it. Okay, because it's not negative, so it's going to move to somewhere here. Here, guess. Left is larger than right. So it's return right here. So it actually matters. I think so. Yeah, it matters. Yeah, because left would cross first. No, does not matter. Anyway, we have this partition here. So it's print begin and print alone. This never happens. That's super weird. Why does this never happen? Okay. I really feel like enough of this today already. Let's take a break today, and we're going to move on tomorrow. So yeah, I'm tired. See you next time, and Learning Kotlin Live episode 15, which will be not tomorrow actually, next Monday. See you next Monday. Bye bye.